All right, everyone, it looks like we are ready to go. So I want to welcome everybody to today's webinar series entitled Building 101. Your presenter today is Gord Rajowski. He's been with us for a few years. He's our national practice leader of building science and sustainability. He has 37 years of applied experience in roof evaluation, diagnosis, design, and repair in North America. He's an ARCA warranty limited approved roofing inspector since 1989. And he's a certified level 2 thermographer and an experienced drone pilot. So he brings to you a wealth of knowledge in the building science world, and especially with roofing and roofing systems. And we're going to talk to you today about some of the important things that are coming down the pipe in the building science world in relation to roofing systems and sustainability. We want to ask you a question before we get started about your level of experience to kind of get a grasp on, what type of people we have in the audience as far as experience level. So if you could take a quick look at the poll there and provide your answer real quick, I'll give you about 15, 20 seconds and we'll move on. So as we go through this poll here, I want to highlight a few things about the webinar today. So you'll notice there'll be some poll questions throughout the day or throughout the morning here that will pop up. I will introduce you to the questions so you are aware that there is a poll question up there. We also do have an opportunity for question and answers throughout the presentation. We encourage you to do so. We've broken the presentation up into sections for you. So what we're going to do is hopefully answer all your questions at the end of each section to kind of keep with the flow of Gord's presentation, but also make sure that we don't get too far away from the points of interest that you guys are asking questions about. All right, so a little bit about Pinchin. If you didn't know who we are, or if you understand us just on a basic level, we are over 40 offices now across Canada, actually. So we extend coast to coast, all the way from Victoria to St. John's, Newfoundland. We encompass building science, sustainability, emissions reduction and compliance, environmental due diligence and remediation, environmental sciences, which is kind of your development studies, bugs and bunnies, hazardous building materials, asbestos, lead, PCBs and such, indoor environmental quality, funny noises, funny smells, things like that, occupational health and safety. We have insurance claim support services, environmental laboratory services, and mechanical engineering and design. So we are a very diverse company and can help you in a lot of ways. But again, today we're here to talk to you about roofing systems. So before we start the overview of today's webinar, I want to put up polling question number 2, which gives us, again, a little bit more understanding of who our audience is. And what is your level of understanding about building resilience and sustainability in a changing climate? All right. So as we finish up the answers there, an overview of today's webinar and what we're going to take you through. We're going to talk about roofing fundamentals, some of the design considerations that you or your designer should be taking, built-up roofing, modified bituminous roofing or SPF roofing, single-ply roofing, fluid-applied roofing, metal-clad, spray-in-place and foam coating, steam roofing. That one's interesting, I find. Sustainability and climate change. So once we've introduced you to all of the points about the types of roofing systems that are common here in our region, we'd like to talk to you a bit about how sustainability and climate change affect how we currently design roofs and what we should think about the future. Non-destructive moisture detection. So ways to evaluate your roof that are less intrusive than before and provide a lot more cost savings, electronic leak detection, and unmanned aerial systems drones. So all these technologies are helping to advance the science of evaluating roof systems and buildings for that matter, and Gord will take you through that. So at this point, I will turn it over to Gord. Actually, just before we get started, I just want to let you know, Gord, that we have about just over beginner levels, about half our class, with another third of our class being at beginner levels. So their knowledge of sustainability and resiliency is entry level for you, but I'll let you have a way with it.
Sounds good. Well, good morning, everyone. I'm glad that you've taken the opportunity to register for this course. I will try to do my best to provide you with information and some experience. We call this internally Roofing 101. So we understand that not everyone is a knowledgeable engineer or roofer or roofing consultant. And what we're trying to do today is give you a little bit of background information to start with. Then we're going to cover the various major categories of commercial roofing system that you may have on the buildings that you are most familiar with. And then we're going to, within those categories, for the most part, we're going to also show what are some common problems that you may encounter or have to deal with. And then we're going to introduce you to some concepts around sustainability and resiliency. And then finish off with showing you how technology is being used in the world today of roofing. So let's get going here with fundamental design, roofing design fundamentals. So the picture that we have for you on this screen is a heritage building. It's actually in a heritage park in Red Deer, Alberta. I encourage you to go there sometime and check it out. But I like this picture because this building was built literally in the 1800s. And as old as this building is, it actually represents for us an example of a structure and a roof that satisfies many of the design fundamentals that we're going to be talking about today. So this building and the roof on it, which is a sod roof, provides shelter. It's part of the structure of that building. Certainly sod is durable. It's an aesthetic, so we can clearly see there's sod on this roof. It's part of the look of that building. For its time, log construction and sod roofs provided some thermal resistance. They were the insulation of their day. And certainly when the pioneers came to Alberta and constructed buildings like this, they did so because they were looking for separation from the outdoor environment and the indoor environment. When we contemplate what the rules of design are, we start with control of heat, air, and water, which deal with over 80% of the problems faced by a building. Controlling heat, air, and water are the keys to creating a durable building. So these are the things that we always start with, regardless of the type of building, the shape of the building, the height of the building, or the use of the building. In roofing design, we have what's called control layers. We have the water control layer, which people most associate with roofing, the part of the roof that keeps the water out. We also have, because we live in the northern climate, a thermal control layer, which is commonly referred to as the insulation. And because we have a cold climate for at least half of the year, and people and operations tend to be enclosed for half of the year, we also have to be mindful of vapor control. So moisture that's being produced by people and the operations that are occurring within that building have to be controlled. So we call that the air control, not the vapor control, but the air control layer. And you'll notice that I make a distinction here. Many of you have heard of something called a vapor barrier. And in fact, many materials are in fact vapor barriers. But what we've known for many years now is if we can control the pathway of warm humidified air, i.e. if we can control air movement through our building envelope, we don't have to focus as much on vapor control because what? Vapor is transported by air. So it's more important that we focus on how to control the movement of air as opposed to just focusing on vapor control. So here's a simple cutaway of a roof assembly. And it shows you, this diagram is actually a diagram of what we'll call a conventional style roof assembly, and we'll get into more of that shortly. But it shows a structure, and it shows the control layers. So the control layers in blue are the air barrier, the insulation, the waterproofing, and then we usually have some sort of a protection on top of the waterproofing. In this case, it's rock ballast. So this is a simple cutaway. To more simply illustrate how the roof is integral to the overall building envelope, you can see that in this simple sketch, the roof is 1/6 if you're looking at it in 2-dimension or 3-dimension, but it forms an equally important component of a building, and it needs to be properly integrated. In many ways, a roof is a horizontal wall, and it's an upside down floor slab. So all of these different components have to be properly detailed, have to be properly considered, and have to be properly constructed. In modern construction, here's an example of a rec center under construction in Red Deer a few years back. And we can see some of the component layers in this photo. So the Q deck that you see here, the metal Q deck, is the structural substrate, the support for the roofing. Obviously, this part here, the black membrane that's peeking out is an air barrier. The green part is insulation. And where the roof and the wall join, and we'll call this on the outside edge the parapet, we have to properly detail and make certain that we've got a connection that allows air and moisture and heat that we want to keep inside the building to stay inside the building. And we also want to repel moisture and wind and other harmful elemental effects from getting inside the structure. So this shows in the early part of construction how we're starting to put the bits and pieces together that create a total envelope. We talked about airflow being important and the control of airflow. So this is a real close-up that shows a plywood base on top of a corrugated metal roof structure, and we're joining to a vertical wall with the red steel here. And so the steel stud that you see up here, these steel studs, are going to be what we'll call the parapet, or the top part of the roof that contains the perimeter of the roof. But what we know in modern construction, that it's very difficult to create an airtight enclosure if we build this parapet structure and then try to wrap and seal and go around and do all of these things. So the preferred way to do this is, let's take care of the connection of the air seal before we build this parapet. So this is just simply showing an example of how we detail to create air tightness at the roof construction stage. Here's an example of construction that where we're marrying an old building with a wood structure to a brand new modern addition that's got a steel structure. Now, how do we ensure that we are going to maintain the control of air, vapor, heat, and be able to provide security against the elements? So in this example, what you're seeing is construction that involves properly detailing or creating the tie-in detail. So this white material here is an air barrier that's been installed, and it runs up the vertical face of the brand new wall junction, and it runs down and goes across the other way. So what we're doing here is we're marrying old construction or existing construction to brand new construction. Once this membrane is in place, then we can add insulation both to the vertical wall. We will add insulation on the horizontal. Insulation will be added on this horizontal, and we're also going to insulate the top of the wall. So when we're done, what we've created is a union or a marriage between the old construction and the new construction that is sealed against air leakage, humidified air leakage. It's also insulated on all sides, and it's protected against the elements. So this is an example of some of the design fundamentals that need to be understood when you are contemplating roofing. One of the most important features of roof design is how to drain or manage water. So whether that is from snow or from rain, how do we properly manage water from the top of the roof down to the site where it can be dealt with by the stormwater management system? A lot of the time we do that with flashings. So very simple term, for those who aren't familiar with the term flashing, it's generally created with pre-broken or pre-shaped aluminum metal that is sized and shaped to suit the job that we need, which basically is to carry water from one plane to another safely outside the building. When we also talk about drainage, we're talking about actual drains. These are internal mechanical drains. They come in different sizes and shapes, and they have different features to either control the flow of water into the opening. We also have protective screens that try to keep the leaves and other organic materials from entering into the drain throat. Detailing is quite important because this is where we want water that's being carried from the top of the roof to enter into our building. And sometimes that detailing is not completed as well as we'd like, and we can actually get water intruding into the waterproofing, which is this illustration here. This is a thermal image. You'll see others of these examples as we move through the morning. Now let's get into what we'll call the configurations of roofs. So for the next little while, we're going to assume that the bulk of the roofs that you are dealing with or may be familiar with on your buildings are what we'll call flat. They're not really flat, but for all intents and purposes for this discussion, we're going to be talking about flat roofing. There's two basic configurations of what we call low slope or flat roof assemblies. One is a conventional design, and the other is called a protected roof membrane assembly, also known as inverted. And what do we mean by that? In a conventional design, the waterproofing, so if we look down to the sketch here, in the lower right, the waterproofing, the part that keeps the water from entering into the building and into the system, is on top of or outside of the thermal barrier insulation, which is outside of the air barrier, vapor barrier, which is sandwiched on top of the structure. So the important thing to understand about conventional designed roofs, the waterproofing is on the outside of the insulation. Some of the pros of conventional design roof systems are they tend to be in this category of flat roofing. They are lighter than the protected roof membrane. There's a wide variety of insulations that can be used and a wide variety of waterproofing. But the biggest pro of a conventional designed roof system is they're easier to maintain and repair, because the waterproofing, the part that we're most concerned about, is visible or close to being visible. It might be protected by some ballast, but we can get at it. We can repair it, and we can find leaks if we have to, and we can do small repairs or area repairs because the waterproofing is close to where we can get at it. The cons are, because we have an exposed membrane, they're more susceptible to being damaged by hail and extreme weather and trades. So when tradesmen come onto your building to service fans or do other work in the field of the roof may be more susceptible to being damaged because they're leaving tools or materials, or they're cutting filters for rooftop units, and they're creating damage. So that's actually a con of our conventional design. The inverted or protected roof membrane assembly, again, for illustration purpose, the waterproofing, the part that we're most concerned about, is here. It's sandwiched between the structure and the insulation. Now, because we have the membrane buried here, the insulation tends to be a lightweight insulation, usually an extruded polystyrene type insulation. This insulation tends to be very light in weight, so it must be held down with ballast and retention fabric. So this ballast adds about 10 pounds per square foot of weight, which makes inverted roofs much heavier than conventional roofs. So interesting thing though is, in the northern hemisphere, the northern climate we call Canada, in design consideration, this is the preferred way to build a roof. If all things being equal, it's better to have your waterproofing sandwiched between your insulation and your structure, where it can be protected, and we can control better the flow of humidified air leakage and heat loss. But from a practical and operational and maintenance perspective, these roof assemblies are difficult to repair. They're difficult to source leaks on, and they can be a challenge to maintain in general. But in theory, this is the best kind of roof for a northern climate. So again, it's a preferred approach. It's easier to tie in this waterproofing membrane, which is your air barrier membrane, to your wall membrane. So in theory, this is the superior way to design. The cons are added weight, tough to find leaks, hard to inspect. The commonly used multiply membrane system, let's back up. For flat roofs, there's typically there's 4 or 5 categories of waterproofing roofing assemblies that are most commonly used. Depending on the age of the building and the style of the building, you may have what's called a built-up roof, which is 3 to 5 plies, a lamination of paper felt adhered with interplied liquid asphalt. They're typically finished off with a flood coat of pea gravel. So if you're on the exterior of a building, these roofs are interesting, are typically identified by the fact that you're walking on pea gravel. The most common style of roof right now in Alberta is a version of what we'll call modified bituminous, or SBS, which has departed from the 3 to 5 plies and is a 2-ply system, which is often thermofusibly adhered. So this roof system was mopped with hot asphalt. We created a lamination in the construction of it using hot asphalt. Whereas this roof to the right could be mopped, it could be adhered, and then the top part of it is torch applied. We'll get into more of that later. Other newer styles of roofs that you may see on the buildings that you're most familiar with are what we'll call affectionately as a rubber roof. It could be a white shiny material, which is either a thermoplastic olefin or a TPO, or it could be a PVC, which is a polyvinyl chloride. What we've done here is, as technology has evolved in the roofing industry, We've gone away from multiple plies, where we had as many as 5 plies of paper felt laminated with hot asphalt, to a single ply using either a rubber or a PVC or a TPO. So these are what we call single ply waterproofing systems versus the multi-ply system. When we're considering the choices that we make for roofs, both in the design and perhaps in the replacement, we have to consider that roofs represent approximately 5 to 7% of the initial capital building cost. They cover 100% of the building and its contents, obviously, but over the life cycle of a typical building, the roofs will need to be replaced a minimum of 3 times. And that's based on a life expectancy of about 70 years. So that gives you some idea of how many times buildings that you may be familiar with are going to receive or require some intervention, which could be a complete roof replacement. Roofs come in all shapes and sizes. This is a gymnasium in Didsbury, Alberta, attached to an elementary school. It's got a very unique shape. Because of where the school is located and this unique shape, it provides a very interesting opportunity for kids with skateboards. So just to show you some of the things that we have to occasionally consider is discouraging kids with skateboards from using our roofs as a skateboard opportunity. So now we're going to move into an area where we're often asked as roofing consultants, so how long do roofs last? This slide is a bit dated, but the information contained in it isn't that off the mark. So what we're seeing is that some roof systems, particularly some brand new styles of roof systems, are really not providing the long-term performance that we are being promised as consumers. So you shouldn't be misled by low price if your objective is durability and longevity. So like many things in industry, the cheaper the product, the less life cycle we get. So EPDM membranes, for instance, we'll pick on EPDM here. There's multiple different configurations of single ply EPDM, but what's happening is we call these roofs developer roofs because they are in the consideration of total development and construction. They're among the cheapest roofs that a developer can choose from to complete a brand new building, particularly in a warehouse situation or a large footprint. If you've got a manufacturing facility, EPDM provides a low cost, economical opportunity. The problem is that it may not provide the longevity and durability that you might be looking for in your roof. So really the opportunity here is when you're going to consider what style or type of waterproofing is most appropriate, cost has to be measured against durability and longevity. Now, if you're a flipper and that's not of interest to you, well, pick a cheap roof. But the guy coming after you or the gal coming after you is probably going to have to deal with the roofing far before they may have anticipated. So again, choose wisely because not all roofs last to the same degree. And of course, there's a cost attached to providing roofs that are longer and more durable in their performance. And that's really what this slide is intending to do is we are often challenged as roofing consultants with, I don't want to pay too much for my replacement roof or my new roof. Can you give me, what's my best choice? And the question has to be first replied with, well, what do you want to achieve? We have several clients at Pinchin that are, they buy and they hold their property, or they build and hold, and their expectation is that they're going to retain the property for many years in the future. So for clients like that, it's logically a better choice to pick a roof that's going to last as long as possible. It may cost them upfront a little bit more, but they're actually getting a better deal because the roofs may last double the length of time that some of the cheaper choices are lasting. And that's really what we're trying to illustrate here. So if your objective is to build a 30-year roof, the upfront cost may initially deter you, but when you consider what what the cost of the replacement roof is, if it doesn't surpass a certain expectation, then you may be, in the long run, better to spend a little bit more upfront and get a longer or better lasting roof. Here's an example of that I couldn't have planned any better for today's presentation. Many Edmonton taxpayers have become aware of the fact that the City of Edmonton embarked on the construction and design, or the design and construction of a brand new Northwest Police Campus. And this particular building has been plagued with roof leaks. I believe the building was substantially completed 2 years ago, and it has done nothing but leak in terms of the roof system. And the conclusion that City Council is now wrestling with is that their 2-year-old building now requires an $8 million roof replacement because of the chronic leakage. So, this is going to be tied up in the courts, because somebody's going to have to answer for why a brand new roof is leaking to this degree, and a 2-year-old building requires a new roof. But this illustrates the point that we were trying to make in the earlier slide, but to the other extreme. When we're contemplating what to do with the roof on an existing building, like as roofs age, what are our options? And without even considering costs and types of roofing membrane or how much insulation and all the rest, owners have 5 options, whether they realize them or not. And these are the options. So the first option is do nothing. As long as you understand what the implication of doing nothing is, i.e., you have a roof that's 15, 20 years old, starting to show some signs of degradation and old age, but it's not leaking. As long as you understand that the roof is not getting any better and it's only going to continue to deteriorate, and you're okay with that, that's a legitimate option. And quite frankly, many of our commercial owners choose option 1 because they might be strapped for cash. Option 2 is maintain. All roofs, regardless of their condition, can be maintained. Some for only 15 minutes, but all roofs can be maintained. And if you are in a position where you can't afford to contemplate a major repair or replacement because the budget isn't there, then providing some degree of maintenance as your buildings age and your roof ages is a good way to preempt or to hold off the larger bill associated with major repair or replacement. Option 3, if you've been doing a reasonable job of monitoring your roof and doing some proactive maintenance, as the roof ages, there's likely going to be a requirement to do some repairs. If you catch these repairs early, again, the bill is less, and we can extend, in many cases, the service life of the roof. So being in a position to understand when it's time to do some localized repair and whether or not it's economic to repair versus looking at more expensive options is a good thing. The fourth option is what we call retrofit. Depending on the style of roof and the use of the building and all sorts of other considerations, it may be possible to leave the bulk of the roof assembly that you have in place and essentially retrofit the part of the roof that is no longer providing good service. So examples of this is where we do something called skin and replace, where the outside skin or the waterproofing on a roof is aged, but the insulation and the other components of the roof are effectively still in good shape. So why do we want to throw everything away? Perhaps we can retrofit by just taking off the waterproofing and retaining the portions of the roof that have been existing and are still serving the building well. So when you retrofit, you're basically able to virtually get a new roof for about 2/3 the cost, half to 2/3 the cost of complete replacement. The fifth option, replacement, is just that. We've decided for all kinds of reasons that the existing roof that we have has to be replaced totally. The problem with option number 5, in a world where we are more and more concerned about filling up landfills and recycling and what are we doing for the earth, replacement is becoming a choice that is less and less popular because as you take the old roofing components off, they have to be disposed of. And we want you to dispose of your old roof in a responsible manner. And to do that, it's going to be fairly expensive relative to what it might have been, say, 25 years ago. So before we get to the fifth option, which is complete replacement, hopefully we have exhausted the other 4 options. And we have reconciled that it doesn't make sense to keep any of the components of the old roof. So again, these are the 5 options that we offer clients and owners of buildings. So at this point, I think we've got a poll question, Corey.
Yeah, so we'll get into our first of the in-between slide poll questions here. So how many of you have been involved with the planning, design, and selection of a commercial roof? Just gives us a benchmark of your understanding on these matters. While we let the poll question answer there, I did receive a question or two through the Q&A. Just a good reminder, there is a Q&A tab at the very bottom of your Zoom. That is the place where you would post your questions. Some of them I will answer behind the scenes as they might be technical or whatnot. We did have one question regarding the slide deck here, and was asking if we can provide a copy of the presentation. The answer is yes, but I'm really curious how many people are looking to get a copy. If you click on the participants tab at the bottom, you'll have the ability to raise your hand. If you could raise your hand for me and let me know how many are interested in this, and then we'll figure it out. So at least half of you. Okay, so what we'll do here is we'll actually email a copy of the slide deck to everybody who's registered for the course here sometime later this afternoon. The other question we had that was not technical related was how often should a roof be inspected for PM? And I assume PM means preventative maintenance.
So the answer that we typically give to a question of that sort is because of where we live in the northern climate, and we have our 4 traditional seasons, we recommend that building maintenance officials make a point of doing some kind of visual inspection twice a year. And those inspections are carried out early in the spring, once the majority of the snow, meltwater, ice has left the surface of the roof, so that you can see what the winter has done to your roof and the components of the roof. So early spring, and then we recommend that you get another, do another review in the early fall, early to late fall, so prior to winter, to make sure that the roof is buttoned up and ready to go for the next winter season. Now, so building maintenance officials should do this as a matter of course. So they should just build this into their PM. We also recommend that after any major or extreme weather, so major storm or extreme weather, that a visual review be carried out for obvious reasons. So, you know, if we've had high winds, if we've had major downpours, things like that, what's happened as a net result of that. Now, how often should you engage a what we'll call a roofing professional, a roofer, a roofing consultant? We recommend that you engage a roofing professional a minimum of once every 2 years. And that's your choice. You could do, many of our owners have relationships with roofing contractors who provide them with emergency leak response, and as a part of their agreement or their commitment, we'll also provide some sort of biannual or semi-annual review. So if that hopefully that answers your question.
All right, we have another question here. So for an inverted roof, does the water flow through the ballast and insulation to the membrane? Question after that, does it drain off the roof under everything using slope of roof structure?
Yes. So simple answer is because of the nature of inverted roofs, typically the buildings are designed by structural engineers to carry more water. So unlike the conventional roof where the water sits on the surface and the drains are placed at the surface, so water running off the surface in a conventional roof will enter into the roof drain. In an inverted assembly, typically the structure is pre-sloped to available drains. Now the difference being between the conventional and the inverted is it is understood that water has to percolate down through the ballast, the filter fabric, the rigid insulation, and get to the surface of the roof membrane, and then it still has to migrate to the drain. And so it does that eventually, but it's not uncommon to come onto a inverted roof a week or so after a major rainfall. And if you were to open up the components of that roof, you'll find that water is still present. So these roofs tend to drain much more slowly than conventional roofs, but they are also designed by structural engineers with that understanding that water is going to linger in the system longer, and it's going to take probably a longer time for it to drain. The drainage can be improved by the type of drain that you use and a few other things that can be done. But the answer is yes, water does eventually migrate downwards by gravity to the surface of the waterproofing, and it will travel to the drain, or it should, if everything is working well.
Okay.
Right, so we're now going to, go ahead.
No, I was just going to say, it looks like that's all the questions, Gord, so go ahead.
All right, so the next chunk of slides, of which I think I got 65 slides here. So I just wanted to let everyone know that once we've covered the next major section here, we're going to have a short break. So we understand that you know, that this is a lot of information to take in. So we've planned a break after this section here called Major Types of Commercial Roofing. So we talked earlier about built-up roofing, and what we're going to do now is kind of show you, you know, how these things are actually constructed and what are some of the common issues that you may find. So in this section, what we're going to be doing is introducing and spending a little bit more time on the major types, membrane types, and roof assembly types, and show you a little bit about how they're built, but also show you what some of the common issues with these roofs are and some of the options available as you encounter these issues. So as you've already learned, built-up roofing is a term associated with a multi-ply, 3 to 5 ply lamination of paper felt with interply asphalt. It forms a waterproofing cover for insulation. So this is a cover board and primary insulation, and this sits outside of the structure. So this is sort of another blow up of what a built-up roof is. And to the right, we see a fellow with a mop and a tar bucket, and we see rolls of paper felt, and literally the roof is constructed in the field by offsetting these rolls of paper, and each roll has a mopping of asphalt applied to create that lamination that we refer to. So once you've reached 3 to 4 plies, sometimes up to 5 plies in this method, this, when it cures together, forms your waterproofing membrane. This type of roof has been around for about 150 years or more. It's a very well understood roof, but it's no longer commonly installed because it can be very smelly. So asphalt tankers and asphalt, as it's heated, casts off a significant odor, which is problematic for occupied commercial buildings. So we have a lot of tenant issues when we build built-up roofs. There's a significant smell in the neighborhood. Also the cost of oil and the ability to get good asphalt, all of these things are impacts on the application of these roofs. So as much as this is a well understood and long-serving style of roof, it's no longer the kind of roof that is still as popular as it once was. As newer systems have evolved, primarily modified bituminous SBS, they are slowly replacing built-up roofing in the marketplace. Some of the problems that we encounter with older built-up roofs, and we illustrate this point this way. Very few owners understand that the old roof that they're building may contain hazardous materials. And what do we mean by hazardous materials? Some of the materials that we built with back in the 60s, the 70s, and even up to the early 80s contained asbestos. So this is an example of a project that Pinchin was involved with in St. Paul, Alberta, on an extended care facility where this older built-up roof needed to be completely replaced, or at least that was the plan. But what wasn't understood at the time was that the old built-up roof contained, if you can see in this picture, there's some chunks of white that are visible. And this is plywood sheathing. And of course, this is the built-up roof membrane. But in between the plywood and the built-up roofing is what we call a dry felt, which is actually asbestos felt. It's 95% chrysotile asbestos. It's a great material to build with. The problem is that when you start tearing it off, it becomes friable, and the asbestos fibers start to be spread into the atmosphere. So if your old building has an unknown composition, the first thing that we recommend is you get that roof composition analyzed for presence of hazardous materials. Because if you have asbestos felt or other hazardous materials or products contained in the old roof, you have to mitigate and remediate that in a much different way than if those products weren't present, i.e. you can't just throw chrysotile felt into the landfill, or you shouldn't by law. And you have to be able to manage the removal of these materials in a safe and contained way to protect both the occupants and the environment. So some of the common BOR problems that we see is, I don't know how many times you'll go on a roof and you'll see that this is a little exhaust vent or chimney vent, and someone is needed to run a cable from a device or a piece of equipment that wasn't originally there. And so they're looking for an easy way to run their cable into the interior of the building. So they look for a curb, drill a hole, run their cable, and then they slap some black stuff on it. So why is this a problem? Because to be fair, each of these penetrations should by good practice have their own designed penetration into the interior. So we can control it, we can seal it, and we can maintain it. When you have situations like this, the seal that keeps the water and the snow from getting into the interior is only as good as this black mastic. So we often see where someone is lazy, or they're taking the easy route to installing equipment. It could be satellite wiring or cabling, whatever is required, and they're looking for the easiest way to do that, but not realizing the implications. If you've ever gone onto a built-up roof and you've seen a situation like this, where with peeking out of the gravel ballast, you'll start to see these lines, and they can be offset a little bit, but they generally travel in the same direction. So in this case, all of these lines are following the east or west orientation, or north to south orientation. What this is called a membrane pressure ridge. And why the illustration to the right shows you how large they can be. Typically, a membrane pressure ridge is created because there is a lack of adhesive bond between the component layers of the roof, meaning the roof membrane, the part that's keeping the water out, is responding independently from the insulation to expansion and contraction. So let me go through that once more. Roofs are dynamic. They don't look dynamic, but they are. Every day as the temperature rises, the roof wants to expand, and as the temperature falls, it wants to contract. And in order for the whole assembly to perform together, all of the components, the waterproofing, the insulation, the air barrier, vapor retarder, and the structure all have to be connected and sealed and working together homogeneously. When that bond breaks down between the component layers, we know that the membrane has a different rate of expansion and contraction than does the insulation below it. And so something has to give. And typically what gives is the membrane. And it causes basically a wrinkle or a ridge, a pressure ridge to form. So there's a very long and technical explanation of what we're seeing here. The issue with these pressure ridges is that as the membrane wrinkles up or creates this pressure ridge and is left exposed over time, the ultraviolet radiation and the elements in general will start to break down the membrane in these locations. And it could cause a split or a fracture that will allow water to enter. A common issue that we have in Edmonton and many other places as well is what we call wind scouring. So as the built-up roof ages, the adhesive bond between the pea gravel and the flood coat starts to break down, and we have a lot of wind typically coming from the northwest direction. But and so it's not uncommon to go onto a flat roofed commercial building with a built-up roof and go to the northwest corner and see an area that's been scoured by the wind over successive seasons. In and of itself, wind scouring isn't a big issue, except that over time, as you lose that protective flood coat, it can cause the underlying components to become exposed and eventually eroded. So the easiest way to deal with wind scouring is to rebroadcast gravel into the area that's been exposed. With older BUR roofs, the other issue is what we call the membrane stripping. So the same roof assembly that we have on the horizontal is used to create the seal at the perimeter. And where this membrane is not protected by a flood coat of rock and gravel or protected by the metal counterflashing, the roof is most susceptible to exposure and degradation over time. So this is an area that we try to pay close attention to when we do inspections of roofs with the system, because we know that 85% or better of our leaks occur at the perimeter edges and at the through roof penetrations. So it's most likely that you're going to suffer a leak to the interior of your building along a perimeter edge. And often the source of that leak is a fracture or a place where the old BUR membrane has become embrittled or dried out from exposure. Another common issue that we encounter a lot on roofs, whether they have BUR or otherwise, is what's on top of the roof. So skylight bubbles, skylight installations, rooftop equipment, chimneys, other rooftop units. Again, as I mentioned previously, 85% of our leaks occur at the perimeters and at the through roof penetrations. So skylights represent a penetration. And we often hear from owners that I got a leak somewhere around the skylight. And it might not be the bubble itself, but it's the way that the curb and the membrane has been flashed in. So here's an example of a roof that I was on recently where we performed an infrared roof moisture survey. And the infrared scan identified that we had wet insulation boundaried by the orange paint. And coincidentally, we have a bubble right there, a skylight bubble. And when we look closely at the bubble, we see that there's condensation already formed. So we know that the seal between the two layers of plexi on the skylight have been, it's broken down, moisture's inside there. Likely the source of the leak to the interior of the building emanates from the skylight, and it's managed to migrate into the roof in this area. Another common source of leaks in buildings with built-up roofs in particular, but in other roof membranes as well, is when rooftop units are placed directly on the roof surface without the benefit of a curb or an insulating material like semi-rigid insulation. In these two examples, the rooftop units are mounted directly on the organic BUR membrane. Now what happens is, particularly on hot days when the roof starts to soften as it gets warmer, and these rooftop units run, they will vibrate their way into the waterproofing membrane and can cause a leak. So once again, under thermography, we've identified this area as containing entrapped moisture, and the source of which is this little air conditioning unit that's worked its way into the waterproofing. So again, there wouldn't have been much effort required to place this unit on top of a couple of inches of semi-rigid insulation or wood sleepers or some kind of cushioning, and that could have been prevented. We talked about protected roof membrane assemblies and the fact that they can be difficult to inspect. Well, here's what I mean. This is a hospital the old Stanton Hospital in Yellowknife, Northwest Territories, and I performed a roof condition assessment on it last September. And it's got an inverted or protected roof membrane assembly, and it's a large building. How does one evaluate the integrity of the waterproofing in a system like this? Well, the answer is it's very difficult. Here's why. So in real time, what you see when you perform a cut test in an inverted roof is this. This is the aftermath of a cut test that we did to evaluate the integrity of the waterproofing, which is the black down here on the inside of this hole. So you have to first remove the rock. This is what we call the retention fabric that helps to keep the rock from migrating into the insulation and helps to balance the roof out from water. And then we've got the component insulation, which is in the blue. So you got to cut through that. In this case, there was, I believe, 8 inches of semi-rigid insulation. And then down below there, we have the waterproofing. So if this cut test is out here, how do we know what the condition of the roof membrane is all throughout here? Very, very difficult. We don't have X-ray vision, and you can't cut holes everywhere. So this is one of the challenges in the evaluation of this type of roof membrane assembly. Some of the other issues that we get into with inverted roofs is what we call rafting. This is a small example of it, but basically, as water is allowed to collect on the surface of these roofs or accumulates in corners or places where the wind will drive snow and water consistently, the rock ballast starts to get moved, which exposes the fabric, and then subsequently the retention fabric may become displaced. Rock goes in between the insulation, and we start to get the insulation floating. So hence the name rafting. So this is a fairly common issue with this type of roof membrane assembly. It has to be monitored on a regular basis. The other common issue that we encounter with this type of roof assembly is these roof assemblies provide a great environment for shrub and plant growth. So it's not uncommon to walk on a protected roof membrane assembly and see trees and shrubs growing from the joints in the insulation between the rock. Let's talk a little bit now about fall arrest and roof anchors for your major types of roofing. As the code changes and the requirements for safety are enhanced, more and more building owners are having to contend with the fact that they can't allow window washing and other window replacement or other needed repairs or inspections on the exterior of their buildings. These things can't be performed the way they used to be, where swing stages could be erected and lines run and wrapped around penthouses and things like that. So where I'm going with this is that more and more buildings are now having to get fall arrest systems installed and designed for their existing buildings. So what we have by way of illustration is an example of a fall arrest anchor. And biggest misconception that exists out there is that once the anchor system, the fall arrest system with anchors is designed and installed, I'm done. So I've got my anchors and now I can just keep going because I've satisfied that requirement. The fact is that these anchors need to be inspected annually, and every 2 years they need to be load tested. So if owners aren't doing those checks, then it would be almost unsafe for a window washer to use your anchors. So what owners need to be aware of and maintainers need to be aware of is these designed components called roof fall arrest anchors need to be re-inspected by a licensed structural engineer to ensure that their load capacity hasn't been compromised by someone or something since their time of installation. So not only should you have a fall arrest plan for your building, which may incorporate fall arrest anchors, you're also going to need to ensure that these devices are re-inspected on a regular basis to ensure proper and safe use going forward. Sometimes when buildings suffer leaks, it's not the roof, but it might be something associated next to or adjacent to the roof. Here's a couple of simple illustrations. Most roofs will have some form of penetration that is designed and accommodating mechanical, electrical devices, sometimes structural components. These designed openings are often sealed with a mastic or some kind of a sealant that creates the seal, the watertight seal between the designed opening and the device that's penetrating through the structure and the roof assembly. These gum boxes or pitch pans, as they're often known, have to be maintained almost on an annual basis to ensure that the integrity of the waterproofing is maintained. So if these pitch pans are not maintained, they can often be the source of internal leakage. Similarly, on walls and joints that adjoin the roofing system, this continuity sealant that you see here, the caulking, is breaking down. Now, this hole may not be a source for water to the interior, but it might be. When water enters the building from overhead, it's often believed that the roof is leaking when in fact it might be something else. So when we do visual reviews on a semi-annual basis or biannual basis, we're also considering this aspect of the building envelope in conjunction with the integrity of our roof. As built-up roofs and even SBS roofs age, they don't automatically need to be thrown away when they reach a certain point. If the roof that you have is performing reasonably well, it's only got minor repairs, maybe a little bit of wet insulation is found, but by and large, the bulk of the roof is performing well, but is aging. An option to extend the life of the system you have is called roof restoration. Roof restoration has been around for over 30 plus years. It was originally focused on built-up roofs, the old built-up roofs, but is now becoming quite a popular alternative as SBS roof membranes age as well. So let's talk about the roof restoration process. The first part of, before one can contemplate whether roof restoration is appropriate, and the reason why you'd contemplate roof restoration is because it represents an opportunity to save money versus doing a complete replacement or even a retrofit. So one of the first things that's done is a roof moisture survey is undertaken to determine what percentage of the roof may contain entrapped moisture. So a roof moisture survey is typically undertaken using thermography or thermal imaging. So the image at the left is a thermal image that illustrates the location of entrapped moisture. And it's marked out. We've seen other pictures in our presentation that show that. So if this were a total area or one section of a roof, and the area that's been compromised by moisture, represents 40% of the gross area, it's probably not economical to contemplate restoration, because you're essentially throwing away or having to remove and replace 40% of your roof. Now, if the area that's been affected by moisture is less than a third or 10%, it's still economical or more economical to contemplate a restoration than a total retrofit or complete replacement. But the candidates for restoration have to be roofs that are stable. So the roofs may not be completely wet, but if they're a patchwork of repairs, they're likely not a candidate for restoration. Some of the processes involved with restoring an aged roof system, and this is being a built-up roof here, but it could be an SBS, is the first thing that's done is we remove the skirt flashing, the perimeter flashing. We vacuum off or remove all the loose material, the loose rock, any debris that's accumulated, and clean off the surface. The next thing that's done is the perimeter edges and all the through roof penetrations are reinforced. And in this case, there's a rubber-like EPDM SBR membrane that's used to reinforce around all the existing penetrations and along the perimeter wall. So perimeter edges and curbs are reinforced. And then a coating is applied over the roof surface. And in this case, ballast gravel is rebroadcast. New flashings are installed. When the roof restoration is performed and executed well, the uninitiated person can't tell that this roof isn't brand new. You're basically leaving a roof that may be 15 to 20 years old in place. You've never opened up the building to the weather other than in areas that require repair. And we are not having to put as much old material into the landfill. So this restoration option is oftentimes a very, very good option for many owners in Alberta and Edmonton area. So now we're going to shift gears from built-up roofing to mod bit SBS roofing. And I'm going to just say here, before we get on to the rest of the presentation, I appreciate that there's a lot of information to be taken in here, but we're going to try to move slowly through the balance of this morning and give you an understanding of these different systems. I'm not trying to make you a roofing expert, but wanting to just provide you with some basic information. So this next major type of roofing system for commercial buildings is SBS roofing. SBS we first became aware of SBS in this marketplace around the mid 80s. So SBS roofing has been with us for a good while now. And the major difference between the old built-up roof and the SBS roof is the waterproofing is much more, it's a superior factory-made product that's reinforced and laminated in the factory. And because of that, we've moved away from 3 to 5 plies, and now we're building a 2-ply roof with the outer ply typically having a granulated, an embedded granulation in it, like a shingle. We often hear the flat roof looks like a big shingle. So this is a SBS roof that's being constructed on a school in Red Deer. And we can see some of the component layers of the new roof. So they're basically what they're doing is they're replacing an old built-up roof, and they're building a brand new mod bit roof. So we see what's called a vapor retarder, which is on top of the old structure. We see the primary insulation. We have a secondary insulation. And at this point, we have what's called the base sheet layer and the base stripping. So a lot of terminology there, but this is the first ply of the 2-ply system. that you see. According to the ARCA, more than 65% of all roofs being built in Alberta are using this kind of technology, this kind of roofing system. The biggest knock on SBS roofs from a installation standpoint is that at least one of the component layers, usually the cap sheet, is torch applied. So we see a gentleman here with a propane fired torch in hand, and he's not paying too close attention. He's about to light his boots on fire. This has been the biggest challenge with SBS roofs is they are manufactured in the field by gentlemen like this using propane fired torches. And if the applicator, the installer, isn't being 100% diligent and keeping an eye on that flame, there is a potential that ignition could occur in areas that are vulnerable to flame. So recently we had a fire during a re-roofing application at the Southgate Center here in Edmonton. And again, I don't know a great deal about the details, but we know that the fire occurred coincidental to a roofing contractor being working on site. The fire occurred early in the morning when the roofers weren't even present. So what typically, or what is not untypical about SBS roof applications using torches is that the ignition may take hours to manifest into an actual flame. So the crew could go away and overnight the ember or the ignition is slowly taking hold until flames erupt. So the story here was that the flames didn't start till like 5:30 in the morning. There were no roofers on the site at that time, but the roof was fully engaged in one portion of the area under construction. So in response to the insurance challenge and the history of fires that have been started by thermofusible operations, we now have school boards and commercial clients who are demanding that their roofs be constructed using flameless methods because their insurance providers are telling them that they will no longer accept torch applied roofing. So the modified bituminous roofing membrane manufacturers are moving towards assembling these systems using cold applied methods. So I'm going to show you a couple of slides of what we mean. This is a school that's being re-roofed in southern or central Alberta. And one of the challenges of old schools is you never know where the electrical wiring is. So once they've exposed the wooden deck, we discover that we've got electrical conduit that's been that was installed traveling on top of the wood planking. And now the roofer has to work around that. But anyway, the first thing that is done in a cold applied roof is the substrate gets cleaned and primed. And so what you're seeing here is a primer that's been applied. And then we call it in the roofing industry, it's called a vapor retarder, but it's really an air barrier. So in this case, this peel and stick membrane is fully adhered to that wooden substrate. And this is the component called the air barrier or vapor retarder, as it's known in the roofing industry. Then the insulation is applied with glue. So what we see here is a gentleman who's got a device that is basically squeezing out a two-component adhesive that is applied to the underside, in this case of the base sheet, but it has also been used to apply the insulation. And so we've moved away from using hot asphalt and torches, and we're now using adhesives, two-component adhesives to create the adhesive bond between the component layers. You see the application of the glue being done here to the back side of the base sheet membrane. So that's an example of cold applied roofing and how the modified bituminous membrane manufacturers have responded to the fact that owners and insurance companies are leery of the way they've been building or are asking their systems to be built. This is just motherhood. It's not a bad thing to review your roof project during a downpour. It's always nice to see what's happening as if the water is actually on the outside or coming to the inside. We're now going to shift gears and talk a little bit about some of the issues that we see with SBS membrane roofing systems. This is a situation called membrane cap sheet wrinkling. So we see wrinkles in the cap sheet. These usually can occur in as little as 3 to 6 months after construction. And so they're an indicator of the fact that we don't have complete adhesive bond between the membrane layers. So the cap sheet is moving differentially to the base sheet, the underlying layer. And when you have this lack of adhesive bond, complete adhesive bond, wrinkles will occur as the roof responds to expansion and contraction. Edge pulling or racking, we've got a couple examples to show you. This is what we mean. We get these wrinkles along the perimeter edge. Left over time, they will produce a fish mouth, an opening that water can enter. So this is an example of that. It's a close-up of a fish mouth, which is just a name for when a lap seam opens up in an SBS system and produces an opening through which water can pass. There's another example of a blister. The nature of, like, this is an older SBS roof. So in this example, the cap sheet would have been installed using a torch applied or propane fired torch. And in these systems, the applicator is taught to make sure that his lap seams are as tight as they possibly can be. So as the guy holding the propane fired torch is applying heat to the membrane, he's spending more of his focus and his time on these edges and less on the interior. So it's not surprising that we don't always have a consistent bond between this edge of the roll and this edge. So here we have tight laps, and here we have a void that's been created because of a lack of adhesive bond between the cap sheet, the outer layer, and the inner ply, the base sheet. In extreme situations, you get a situation like this. So when your roof has reached this point and you've got blisters and things that are occurring at the lap seams, it's just a matter of time before one of these big balloons, if you will, starts to fracture and water enters. So this is a fairly extreme example of a roof system that lacked adhesive bond during construction. It may have been built in the wintertime. There may have been latent materials present between the different layers of the roof membrane. There could have been wind. There could have been a whole lot of different factors involved that led to this example of a roof failure. This is a roof that I looked at in northeastern Alberta just recently. And this roof system that you're seeing here is 2 years old. The owner of the building, which is a municipality, a municipal government, isn't too happy. What you're seeing, in effect, is that the outer layer of SBS, the granulated cap sheet, is actually not the issue. The issue is the under layer, the base sheet, was mechanically fastened. So basically they used the bottom layer. The bottom layer was screwed down into the substrate. as one of the methods of attachment. And what happened was the screwing, the fastening of the base sheet layer wasn't done correctly. And we've got a situation where the fasteners were over torqued and there's been some movement. Now, every place that there's a screw, we actually have a telegraphing, a melting, if you will, that occurs that's showing up in the outer layer, the cap sheet. So if we were to run a tape measure, we'd realize that there's a fairly even spacing that occurs between these locations. Now, this is only 2 years old, and we know that if there isn't some sort of intervention, that this roof will not survive beyond probably another 2 years before these screws start to poke out and create openings for water to enter. This is an image taken from my drone that shows the extent of the concern. So literally we can count every fastener that the roofer installed here. And it just represents the magnitude of the concern. This is another example of membrane racking. This situation is on a roof in Saskatoon, Saskatchewan, commercial retail unit, CRU building that, again, the roof system is only 2 years old. And what is causing this issue is we have a lack of adhesive bond in the underlying insulation at the junction of the parapet, the wall, and the roof. And what's happened is as the wall is moving in response to temperature and the roof is moving in response to temperature change, the weakest link in the system is the membrane right at the roof to wall junction, which is not adhered well to the insulation below or inside. So again, a lot of these issues that we see in these membrane systems are a function of a lack of adhesive bond between component layers. But the owner of this building is not too happy. They've paid for a brand new roof, and within less than 2 years, the roof is demonstrating this condition. Left unchecked, the roof will not survive beyond another year or two. Sometimes the application of the roofs is done in a less than stellar manner, which can produce leaks along lap seams. And so one of the ways to detect whether or not moisture has been entrapped, as you've already seen, is using thermal imagery. So this shows what we see walking on the roof. We may experience some softness underfoot. An infrared camera will see that as being an area where moisture has become entrapped. Another major example of problem that we're seeing with SBS roof membrane systems is a lack of or a loss of granulation. So at one time, this roof membrane looked like a shingle would, where granulars would be fully embedded and we wouldn't see any black at all. And over time, the granulars have lost their bond. They've become detached from wind, water, and weather exposure, sun, producing a situation where we have very little granular left. And the granulars in this case are necessary to keep the top surface of the roof from being overexposed to ultraviolet radiation. So as you lose the granulation, your roof becomes susceptible to degradation from UV. So that's SBS roofing. Let's move on now to single ply. So we've talked to you a little bit before about different single plies. One of the most popular types of roof membrane for large commercial warehousing in the city of Edmonton, where we've got 80,000 square feet, 100,000 square foot roof areas. Developers will often choose a system like this. because it represents the lowest common denominator in terms of cost. EPDM rubber roofs are single ply. It's basically like installing a large rubber carpet. And you can see in this example illustration, we've got 5 guys pulling on a carpet of rubber. And they're after the insulation and the other components are placed. And these components are often placed loose. So you basically, once you've got your steel deck exposed, you loose lay your insulation and you bring out your carpet of rubber, and then you seam it together, glue it together at the panels, at the panel laps. So large areas of your building can be closed in a very short period of time. We were involved in the construction of one such building, and my recollection is that 80,000 square feet of warehouse was roofed in within the matter of 5 days or less. So from a construction perspective, from a construction scheduling perspective, these roofs can be installed in a very short period of time relative to other roof systems. Because of the nature of the roof systems and the manner in which they can be applied. Another growing and popularity system is a single ply using either thermoplastic olefin or PVC. So these are thicker sheets. They are often colored white. They can be gray. They can be other colors. So if you think of the Calgary Saddle Dome, the original roof on the Saddle Dome had a membrane like this, a membrane system like this. The new Rogers Place, Rexall, or Rogers Place in the Ice District has a roofing system similar to this. So we're using large panels of polyvinyl chloride or TPO membrane, and they are glued in place, they are fastened, or they can be seamed. So these roofs are installed using a multiple of methods. They're all cold applied, and this shows you a little bit about how they are constructed. So unlike the rubber, these roofs tend to be adhered or attached. They are more labor intensive to build, and they are more expensive to build than a rubber roof system. So in order of labor, the built-up roof is the most labor intensive, followed by the SBS, followed by one of these choices. And then lastly, the rubber roof system, the EPDM roof system, is the least labor intensive to install of the major categories of commercial roofing. We've talked about fires, we've talked about flameless roofing and cold applied roofing, starting in the United States, but making its way into Canada. There's a large movement on commercial buildings to go with something called a fluid applied roof system. The best way to explain what a fluid applied roof is think about paint. Think about thick paint. Fluid applieds are typically making their way into our marketplace as an option for restoration rather than as a brand new roofing system. So typically we see fluid applied roofing in Edmonton in places where we have a metal roof that's starting to fail, and we can use this approach to restore a metal roof. We'll get into more of that later. The methodology for applying a fluid is either by a roll, a brush, or a spray. Once you're done, you've got a finish that's usually smooth and shiny, and it's a fairly clean looking option. It's obviously monolithic, meaning that as it cures, There's no laps or seams to be worried about in the future. So as long as you understand what you're buying and how it should be applied and the correct weather that it needs to be applied in, this is becoming a popular option for many commercial building owners. So this is called fluid applied roofing. Some of you may have roofs that have a pitch to them. They're no longer what we categorize as a flat roof. And we're moving into what we call steep slope. So commercial retail units where the roof figures prominently as an architectural feature. A lot of these buildings have what we'll call metal clad roofing on them. So the next few slides are intended to show you how these roofs are actually manufactured and installed in the field and what some of the components are of a metal clad roof. So in this first slide, we show this little trailer, and many metal clad roofs in Alberta are what we call job site manufactured, meaning the roofer brings a piece of equipment like this where they bring flat steel panels and they create a profile pieces that are manufactured in the field that are built and cut to size for the application that they have. So this is called job site manufacturing, where you're producing the panels that you need to clad the building that you have, and the panels are cut to suit to the application that you have. So this is how you build a metal roof. You start with the valleys, this flat stock in here. So this is actually a underlayment that's applied to the outside of the surface. It's quite important because in case the metal ever suffers a leak, we've got another surface here that will allow water to run across the top of it without leaking into the building. Now the panels are brought in, and in this case, the panels are running opposite the direction of the valley. They're set into sealant, and then they are clipped and fastened into place. So if you've heard the term standing seam, what we're talking about is this. This is the vertical profile, the seam, if you will, between one panel to another panel. And literally the seams are crimped together using this device, and we've got the standing seam. So the waterproofing nature of metal clad roofing is water can't leak through an intact piece of metal. So there's no leaks that will ever occur in this area here. If the seam is not well crimped or some damage occurs, water might enter into here. But more than likely, the only place the metal roof will leak is along joints like this, or where penetrations occur through the metal clad roofing. So in this last set of illustrations, we also see ice guards, snow sliding guards that we install because we often get snow hanging up down here close to the downslope edge. Older metal clad roofs do exhibit problems, and we need to be aware of those. Older metal roofs will have exposed fasteners. They look like this. When they were installed, they would have been the color of the metal. These screws will be installed with a neoprene gasket. You can see it there. And over time, as these fasteners are exposed to the weather, and as the roof is exposed to constant expansion and contraction, the screws will loosen, these washers will dry out, and you will have a hole through which water can pass. So making sure that your exposed fasteners are still screwed tight. If you have a loss, if the screws start to back out and these washers break down, it's time to replace these. The other place where we often get leaks in metal clad roofing is at the through roof penetration. So again, the leak's not going to occur through solid metal, but it will occur where we've driven a vent or a stack through and that we have a seal that may be breaking down. We talked about leaks at panels. So you can always see where somebody thinks the leaks occurred because they bring out the caulking gun and they start to smear caulking. So we've got rusty screws, we've got sealant here, and we have a leak somewhere down below. In this case, we also have a situation where the coating on the roof cladding panels is starting to blister off, causing an aesthetic issue. So in summary of metal clad, some of the common issues is the panels might rust. The panels at the laps might start to leak. Often on pre-engineered buildings, we have concerns with ice damming. And as the roofs age, they don't look great. And there could be a concern with energy efficiency. This is in our northern climate, particularly in warehousing situations. The further north you go, these problems tend to be a little bit more prolific. This is in Fort Nelson, British Columbia in early December on a pre-engineered warehouse building that is exhibiting extreme ice damming at the roof to wall junction, and also an overflow scupper situation, which looks very actually kind of cool. Nice big icicle there. These icicles are anywhere from this one being the longest, but typically are running at 5 to 8 feet long, and they represent a hazard to anyone who's walking along the perimeter edge. That's called ice damming. What can we do with these aging metal roofs? The first thing that we want to talk about here is when pre-engineered buildings are designed and erected, they're conceived with a certain limit on what we call dead load, meaning the engineers that design pre-engineered buildings typically design them to satisfy whatever code is current. But as pre-engineered buildings age and the requirement for snow load changes, meaning that the demand for buildings to be able to carry more and more snow as climate changes, some pre-engineered buildings are no longer keeping up to the increased requirement for snow load. So when we're dealing with aged roofs, aged metal roofs that are leaking, we have to keep in mind that there's very little weight that we can apply typically to an aged pre-engineered building with like a metal clad roof. So understanding what the capacity of the structure is the first thing that we need to understand. So with that being said, we can contemplate retrofitting with another metal roof. So a popular approach with aging metal roofs is to simply put a piece of insulation over top of the old roof, create a leveling surface, if you will, and then mechanically attach another panel of metal over top. So you create a sandwich of two metal panels, if you will. This is a good idea if you've got the budget. This is expensive. And also the fact that if your building can tolerate the load. Again, with those structural considerations in place, another option for aging metal roofs is to put another kind of roof system over top. Use the metal as your substrate. Use pre-cut insulation. In this case, we fastened a plywood to create a nice surface to attach a single ply membrane to it. This is very heavy. This is also very expensive, but it was an appropriate solution for this particular school. the roof system was then completed with a single ply TPO. So we went from an old metal roof that's faded and green and starting to leak to a system that looks like this. We've talked previously about fluid applied roofing. Here's an example of where fluids are now entering in the marketplace in the greater Edmonton area as a treatment option for aging and rusting and leaking metal roofs. So basically, contractor comes with the spray, and it's a two application spray. We put a base coat on. All of the seams, the fasteners, and the penetrations are reinforced with a fabric mesh and spray. And then the entire roof is coated so that you eliminate all the rust and all the rest, and you create a consistent aesthetic that looks something like this. So if you've got aging metal roof systems in your inventory, using the fluid applied option is becoming a popular way to basically preserve the service life of that aging metal roof. Not as popular, but certainly there are a number of examples of this type of roofing in the Edmonton area, so we're bringing it to your attention today. Sprayed in place foam and coating. So what is it? Well, first of all, it is basically applying a 3-pound foam that is sprayed. So they have a pump mounted in a vehicle typically that's parked somewhere down off the on the adjacent the rooftop, and they pump the spray up. And you've got this gentleman here who is applying, in this example, he's actually applying a coating, the silver coating, but it could just as well be the 3-pound foam. So you're basically creating a roof membrane using 3-pound foam and finished off by an ultraviolet protective coating, which is usually a little more than thick paint. And the promise from the applicators and the manufacturers of these products is that the foam, when it's fully cured, represents a waterproofing solution that is lightweight. It creates a good insulating value, and it adheres and adapts to the contours of the building and the situation that you have. The challenges with this type of roofing system is that everything is dependent on how well this guy is mixing the chemicals that go into creating the formulation for the foam at the point of application. If they haven't mixed the chemicals correctly, you will have inconsistent application across the surface of the roof, which can lead to everything from debonding and to a great deal of disappointment in terms of the performance of that roof. The other thing that I don't really care for about spray foam roofing is, notice this guy's got a respirator on and a Tyvek suit, but these guys must be the expendable crewmen because they're not similarly equipped with safety gear. So we find that some of the applicators of spray foam, particularly on the roofing side, aren't exactly the best prepared companies when it comes to safety and making sure that the crew are being protected. Overspraying occurs when we have wind. So this guy's holding up a shield to try to control overspray, but sometimes this isn't very effective, and we can also have situations where overspray occurs on walls and cars and people that it might be in the area as the application's occurring. But when the application is done well, you will get a finish that looks something like that. During the application, the thickness of the insulation is measured so that we are assured that we've got what we're paying for. So just a couple of shots about spray foam. And then we're going to finish off here quickly on this section with steep roofing. So we're all familiar with asphalt shingles on our homes, likely. Not as popular for commercial buildings for different reasons, but for commercial retail units, strip malls and such, asphalt shingles have been around for a long time. I think most everyone understands asphalt shingle roofing, steep roofing. The keys here are to make sure that you understand that when you apply a shingle on an angle, this is not a waterproof system. This is what we call a water shedding system. And to ensure that water doesn't enter into your building, there's another component that you can't see in this photo, which is called an underlayment. And underlayments are required so that as the asphalt shingles fail or get removed by wind or damaged, that there is an underlying surface layer that will transport water downslope safely away from the interior of your building. Also, in our northern climate, because of heat loss, we also require an ice and water shield membrane, a fully adhered peel and stick along the bottom 3 feet of the roof to prevent moisture from backpedaling in spring thaw conditions. So other examples of roofing materials, we might see this on some of the on older buildings certainly, but for certain aesthetics, we might see some cedar shakes or cedar shingles. This just shows the Centennial Library in Red Deer undergoing roof replacement. This part of the library is considered a heritage building, and so the old cedar had seen its day come and go, so it's being replaced. And what you're seeing here is the component layers of a cedar shake roof, where we've got a thick felt underlayment with successive units of cedar shake that are being mechanically fastened. So more shots of cedar shakes. These are cedar shingles, basically the difference being the unit size and the thickness, but it's wood. A lot of issues with cedar in our climate because of how dry the air is here, and cedar not being natural to Alberta forest areas. So we see a lot of splitting and checking and other issues as these roofs age. Some of you may have situations or buildings that have clay tile or concrete tile. We see this typically on some very high-end homes in Edmonton, but we also see it on some commercial retail situations. And again, whether it's a concrete tile or a cedar shake, we always want to see a drainage substrate, a drainage membrane underneath the tile to ensure that if water were ever to get underneath here, it can be carried safely by gravity away from the interior of the building. Okay, so at this point, we're going to take a break.
Yeah.
And how long a break shall we take?
Take about 10 minutes here. That'll take us to about 5 after, 10 after. We did have one question at the kind of the beginning of this section, but I'm pretty sure you kind of covered most of this. Maybe just summarize for the group. The question was, what are some examples of what to look for when performing a visual inspection of a roof? And I'm pretty sure you were very detailed about that, but maybe just some, yeah, he says it's been answered, but
okay,
I guess we can move on then.
All right.
Okay.
And
all right.
Again,
10 minutes, everyone. And then we will be back. I have 10:56, so we'll be back at 5 after, and we'll continue on. We'll get started in about 1 minute, everyone. All right, so we'll get back started here. We have some questions that popped up during the break from the last section. We'll get through those real quickly, and then we'll move into what I consider probably the most interesting part of this discussion, which I think you'll find very interesting as well. But it's quite a bit quicker than the history and the details of how a roof is made and some of the problems. But anyways, first question, what is some advice for ensuring QC during roof construction for owners who are not roof experts?
So the best way I could explain, the best advice I would give is consider retaining a third-party inspector or roofing professional as part of the process for building or replacing the roof that you've got. So you want, if you're not a knowledgeable enough about ensuring that the application of the roof that you've chosen or had chosen for you is being done in accordance with best practice, then I would encourage you to retain a third-party resource. The ARCA identifies on their website several examples of independent inspectors that can be retained. But again, I would avail myself of a third party that would advocate on your behalf.
Right on. Second question, how are blisters in SBS roofs repaired?
So the rules of thumb on blister repair are as follows. Typically, if the blister doesn't enter into the lap, so the sides of the panels, SBS panels or rolls are typically 3 feet in width, so 36 inches wide by about 10 meters long, or as many as 10 meters long. So when a blister forms in the SBS membrane, if the blister is contained between the lap edges and it's not impinging on the lap edges, sometimes all we'll do is leave it and monitor it. If the blister continues to grow in size, there's a couple of different things that we can do. Typically what's done is the surface is scarified around the blister area. The blister is cut open. The surface between the ply that's exhibiting the blister, which is usually the cap sheet, and the base sheet is cleaned, and then adhesive is put in place, it's glued back down, and then it's patched. So that's the methodology for addressing a blister. So we start with, where is the blister located? How big is it? Is it causing us any problem? Maybe we'll just monitor it and keep an eye on it. And as long as people aren't stomping on it and walking over it and causing further damage, generally blisters can be left alone and monitored until such time as you actually need to do a destructive repair, if you will.
All right. Next question. In what circumstances do you perform flood tests?
Flood tests are generally are not typically asked for. Maybe they should be, but they're not typically asked for during the construction sequence. But we do see in certain specifications where an architect or a developer or a general contractor requests a flood test to test integrity of the applied roof membrane system. So the best time to do a flood test is when the membrane has been completed and all of the perimeter detailing has been completed. So we're basically substantially complete, that's the time to do the flood test. And the way the flood test is typically done is you do what's called pigging the drains. So we close off the drain openings and we allow water to accumulate on the surface by a hose or whatever method we have. And then we watch and wait to see what happens. So the problem with flood testing is in our climate, if you call for a flood test in your specification and the roof is completed in October, you're going to create a skating rink and add a whole bunch of weight. If you do that in the summer, maybe you're going to be just fine. But there are other methods which we will get into in the latter part of our presentation today that I would suggest maybe a preferable way to test your roof integrity.
Right on. Okay, I'm going to put up the next poll here before we get to the last question. So poll number 4. It's ready to go there. Yeah, there we go. What type of roofing is on the buildings that you are most familiar with? And as that poll runs, we will ask the last question of the group here. Could you provide a little bit of detail or provide some detail on ARCA, what it is, what are the benefits of using ARCA versus non-ARCA, and some of the warranty implications?
Okay, so ARCA, also known as the Alberta Roofing Contractors Association, it's technically known as the Alberta Roofing Contractors Association Warranty Limited. And that's an important thing to know because the common understanding is that ARCA is an independent body of roofing knowledge, and it is not. It's a limited company whose shareholders are the 15 to 20 major roofing contractors in the province of Alberta. So some of the larger roofers that you may be familiar, say Flynn Canada, Akron Roofing, people like that are shareholders. They are owners of the ARCA. Now, what does that mean? It means that, number one, the ARCA does not represent all roofers in the province of Alberta. They only represent the top 20 or so provincial roofers. But what the ARCA does do is provides a great deal of information that can be accessed freely on their website called arcaonline.com. And there's lots of best practices and information on how to construct roofs according to the ARCA. Some of their preferred not contractors so much, but preferred methodologies for assembling roofs in the province of Alberta. Now, getting to warranty, the ARCA has several types of warranty that are available to commercial owners and residential owners. And it depends on how much you want to pay and what kind of system that you want to construct. But the most common warranty the ARCA provides is a 5-year term. It's a limited warranty. And what I want to say about warranties in general, not just ARCA specifically, is warranties are written to protect the liability to the writer. They are not written for the protection of the owner. So if you think a warranty is going to protect you from bad workmanship, poor materials, leaks, you may be mistaken. What warranties do is they limit the response that the underwriter will provide. So I'm not saying don't buy warranties. What I'm saying is put more of your focus on creating an appropriate design built by a reputable contractor for a fair price, and pray that you get good weather during your construction, and you're going to get a roof that's going to hopefully meet or surpass your expectations. warranties are required by companies as a sort of a surety against what's been created on their behalf, but they're not intended for the protection of the consumer. So that has to be really well understood. So you can buy warranties from manufacturers. So the same manufacturers that the ARCA endorses in their warranty program, you can buy their manufacturer's warranty independent of the ARCA if you wish. But the ARCA has been around since, I believe, 1968. They're very well established in the province of Alberta. They do provide a great wealth of information on roofing and roofing application, and they're a great resource that you can definitely avail yourself of. To get an ARCA warranty, you should understand that the roof that you intend to build has to be built in conformance with their best practices. So it has to be a roof system that the ARCA endorses, using products and systems that the ARCA endorses. It has to be constructed by an ARCA member contractor, and it has to be inspected by an ARCA approved inspector. So if you satisfy those three requirements, you can get yourself an ARCA warranty. What that means for some owners is that if they really have a good relationship with one of the independent roofers in the city who are not members of the ARCA, they can't get an ARCA warranty. So the ARCA warranties are only provided when you build the roof the way the ARCA says you should, built by one of their member contractors and inspected by one of their endorsed inspectors. So hopefully that clarifies it. So there's limits and some exclusions, but mostly there are many roofers who are very, very good at their jobs that aren't members of the ARCA. And so if you have a good relationship with a contractor, you've been treated well and they do a good job for you, the ARCA may not be your avenue to go. So, all right.
Yeah, so, okay, we got about 40 minutes left, Gord, and for the sake of really getting some good conversation about probably some of the more important parts, which is the sustainability and climate change, let's get moving.
All right. So let's move into sustainability and climate change. This is an area that is really gaining momentum and focus as we move through. So under this section, what we're going to do is we're going to talk about what makes a roof sustainable. We're going to talk about garden roofs or vegetative roof assemblies, green roofs. We're going to talk about white roof membrane assemblies, blue roofs, which many of you might not know about. And then we're going to talk about what are some of the climate change effects that managers, maintainers, developers need to be aware of as climate changes in Canada. So let's talk about sustainability. Sustainable has many interpretations. This is a shelter from a friend's cabin in Northwest Territories. This is sustainable. It's just a tent basically with a plywood frame, but it's pretty sustainable for his purposes. But really, a sustainable roof is one that must outperform its contemporaries. We're looking at combinations of systems and technology that are going to allow a roof to have a service life of greater than 30 years. That's what I call sustainable. We're not replacing the roof every 10 years and throwing a bunch of components into the landfill. It might qualify for BOMA Best or LEED. May contain recycled material. It might have a reflective surface to it, or it might be vegetative, i.e. have plant media growing. So my thoughts on cool roofing membranes. LEED and a few other areas have promoted white reflective roofs as a means to keep the building cooler and being better for the environment. My thoughts on cool roofs is these are roofs, white reflective roofs should be applied in locations where significant air conditioning is needed. And that's not really Edmonton, Alberta, Canada, because 6 months of the year or more, we typically have white roofs that Mother Nature provides. It's called snow. So I'm not sure that the benefits of white cool roof membranes can be really achieved in our climate. That's my opinion. A vegetative roof membrane assembly is composed of four essential component layers. So we still have the roofing part. So we want to remember that there, underneath all of the stuff that's great and wonderful, is an actual roof membrane assembly with insulation, just like it would be on in other scenarios. But the green roof part is composed primarily of a continuous waterproofing layer. It's got a drainage system that manages water that flows and percolates through from the top to the bottom. It's got growing media to allow the plants to thrive. And then it's got whatever the plant growth, the plant material actually is. Before you can entertain putting a garden roof on your building, you really need to understand what capacity your building has to tolerate the additional weight of a green roof system. It's not just what the system weighs when it's dry, because when there is substantial rain or irrigation present, this vegetative assembly will add considerable weight or dead load to your building, which can actually compromise some existing buildings. So when you design for and plan to have a vegetative roof as part of a new building, your structural engineer will take into account all of the loading issues. But when you are contemplating adding a garden roof to a building that's been there for 25 years, you really need to understand, can your building accept the new and additional load? Very, very important. Vegetative roofing's been around for hundreds of years in Canada. We call it sod roofing. We showed you an example in Red Deer. Here's one from Nova Scotia. Modern vegetative roofs exist around us. If you've been to Vancouver on the waterfront, you'll know the conference center in Vancouver has a vegetative roof assembly. They're very attractive, very nice, also very good for our climate. Really, sustainable roofing can be achieved by having a motivated and fully engaged client who's going to be committing to the maintenance of the roof during its life. You want to have, hopefully, a consultant that has local knowledge of your system and listens well. You have an appropriate design for your building. You have a motivated and fully engaged contractor in good weather. If you have these 5 things, and maybe you don't need the consultant, maybe you can get away with just a great contractor and a good design. But if you have 4 of 5 of these things, you're going to have a sustainable roof. Let's talk blue roofs. What do I mean by a blue roof? As climate changes, what we know is that when we have rain, because we don't have it always, but when we do, generally the rainfall is of longer duration and maybe more intense and deposits greater volume than in the past. This is the general experience with climate change, is that you're going to see what we used to call a 10-year rainstorm more frequently. So is your building equipped to accept the intensity and the volume of water that's falling from the sky and has to be managed in the stormwater system, starting with the rooftop. So there's a movement in the design community to say, well, you know what? If I've got a building in an area that's older and mature, it's a 40 or 50 or 60-year-old neighborhood, chances are the municipal stormwater system isn't equipped to deal any better with climate change than the top of my building is. So as part of mitigation against extreme rainfall, why don't we contemplate using the roof as basically a reservoir? And as long as we've correctly provided for that in design, we can use that water that's falling and collect it and be able to use it in ways that are positive, both in our building and around our site and in the community. But again, to do this, you've got to have a robust structure, and you've got to have valves and controls and the ability to manage the volume of water that's being accepted. So, but blue roofs, you're going to hear more and more about them as time passes, because it presents an opportunity for owners to capture and reuse stormwater in a positive way within their building and around their site, and will help to prevent situations where the stormwater system may become overtaxed as climate continues to change. So the illustration on the right shows the finished product on a blue roof. So there's a lot of components, but the blue roof looks something like this. So we're harvesting the rainwater, if you will. Many of you are well familiar with what happened in Fort McMurray in 2015 and in Slave Lake in 2011, I believe it was. We have wildfire. We are surrounded by boreal forest, and some of our commercial buildings and buildings in general are vulnerable to wildfire. So if your building is in a location where it could be threatened by a wildfire, it's quite important to consider the roof that your building has and what could be done to mitigate against the effects of wildfire or fire in general. So to avoid a scenario on the left, we consider a scenario on the right, which uses a metal cladding that's married to fire-resistant insulation layer. So if your building is in need of a roof renewal or a roof replacement, and you're in an area where wildfire is a likelihood, we want you to consider going to a fire-resistant option, which could be like the one on the right. Every winter and spring throughout Canada, we occasionally are presented with news that another building has collapsed under weight of snow and ice. So again, as part of climate change, we're also seeing in parts of Canada where we have a great deal more snow, and that snow has to be managed on top of aging infrastructure. So we've got, typically we hear about, it could be anything from a CRU building to an arena to a barn. These are the typical classifications of buildings that are most affected, but in general, it could be any building. So the understanding that your aged building and aged structural diaphragm might not be robust enough to meet extreme weather, extreme snowfall, more loading from snow. If you're concerned at all about this, you need to retain a structural engineer who can come in and do an assessment of the structural capacity of your building. And if required, the structure can be reinforced to make it safer in the face of extreme weather. During re-roofing operations in winter, which does happen, this is a school in Didsbury, I believe. No, not Didsbury, but anyway, it's in southern Alberta, Innisfail. If you're having to do a roof replacement during the winter and snow is falling, what is the contractor doing with the snow in the area that he's working relative to the rest of the building site? So in this example, the general contractor who is constructing the gymnasium to the left needed to move the snow to allow roofing operations to continue. So they basically took the snow from up on top of the new gym and deposited it on the adjoining roofs on this part of the school that wasn't being replaced or having a roof replacement. This created cracking and damage to the wood frame structure below the area where the snow was being piled. So you could say, well, that's just dumb. That's common sense would dictate that the roofer or the general contractor and roofer should have known better, but sometimes they don't. 2 weeks ago, central Alberta sustained a heavy downpour. These pictures are from a commercial office building, a 2-story office building in a industrial park just outside of Black Falls, Alberta. Just during the time of the storm and prior to the storm, the building was undergoing a roof replacement. And prior to the roof replacement commencing, everyone who was associated with the project noticed that the small square-shaped roof, maybe 10,000 square feet in area, had been provided with 4 drains, like you see here in the left photo. So 4 drains for a relatively small roof, that sounds pretty good. No one actually did a calculation to see if the drains were of a proper capacity to handle rainwater, but the building's been there for like 20 years, so what's the problem? Well, the problem was that this summer storm in Black Falls area 2 weeks ago dropped such a volume of rain over such a short period of time that all 4 drains essentially became overwhelmed. And then the drain connections burst and the water flooded into the 2nd floor, resulting in considerable water damage. It was after the fact that it was discovered here in the right panel that all 4 drains tie into one common 6-inch main. And under the intensity of that rainfall, this system could not manage that great a volume of water. And so something had to give. So the point of these illustrations is that just because the roof drains that you have and the building that they're in have been serving you well for the last 20 years, you should consider what's going to happen as climate changes. Do you have emergency overflow scuppers? When was the last time you had a mechanical engineer contemplate if that drain system needs to be updated because of the changing weather patterns that we're now involved with? So like it or not, what worked 20 years ago just fine and might be working well even at this moment might not work as well as climate continues to change. And the intensity of our storms and the volume of water that's being directed at our roofs is increasing. And that's really the point. Tornadic winds, depending on what part of Canada you live in, and we all live in Edmonton, we're going to presume, but while we've only really experienced one major tornado that some of us who are a little bit older can remember, in 1987, I believe it was, we know that there are a lot more windy days in Edmonton than I can remember as a kid. And the intensity of wind is also increasing. It's a byproduct of climate change. So when we consider the effect of wind and tornadic wind on our roofs, we can see that wind can do a great deal of damage, and just like the intense rain. So do we have, I guess the essential question is does the building that you, the building that you operate, does it have the kind of roof system that's going to be able to stand up to intense wind? For instance, if you have a roof that's covered in rock ballast, under the conditions of a tornadic wind, the rock ballast becomes a projectile. It's going to send rocks spewing out into the community. You may have a situation where the rock ballast could be removed, and now all of a sudden your roof is subject to uplift and all your roof insulation is blowing across the neighborhood, your flashings and such. So if any of these conditions have become known to you in the past, then it might be time to consider an alternate style of roof that's more resistant to uplift and tornadic winds. That's the message here. This is just motherhood. Roofing in the winter is a mixed blessing. We've got lots of issues when roofers try to work in the winter. A lot more focus needs to be paid towards ensuring that the roofs are built well. This is an example of tying in brand new construction to an existing built up roof. What you can't tell from this photo is all of these peel and stick seals are basically adhered to ice. None of this is sealed. But if no one is keeping on top of these fellows who are building the roof, are they actually going to replace these seals? So the requirement to work in extreme weather in Alberta has been with us since Edmonton was first a place, but being able to do it well and understanding that climate's changing and that we need to be more diligent in how we apply and work in the changing weather. So we're now into the second last part of our presentation. How are we doing there, Corey, for time?
We're starting to run short. We're about 20 minutes left. We'll put up our next poll question here real quickly. So has anybody ever experienced a situation where extreme weather, wildfire, windstorm, downpour caused a problem for a building that you were involved with? And it doesn't look like we have any questions for this section, Gord. So I think we're good to move on.
All right.
Yeah, last two.
So the second last section, we have 15 slides left to go. I'll talk fast. I wanted to introduce here some techniques and technology that's being used to help owners understand whether or not they've experienced damage from water ingress, and some of the technology that's out there to help owners better manage their situation. So nobody wants a situation like this where the water's come in, the damage is resulted, and the tenants aren't happy. So there was a question posed, what can you do to make sure that the roof is being built well, if you don't know a lot about roofing yourself. So there's various techniques that can be used both during construction and then post-construction. Three of the technologies that I have on the screen are, this is called a Tramex. It's an electronic capacitance meter. It's basically a little cart with a sensor that you push over the surface of the roof, and if water has penetrated, it will send an electronic pulse down, And if it hits either water or metal, it will create an alarm, and then that can lead to further investigation. But this is called electronic capacitance. During construction and even post-construction, but often during construction, a device like this can be used. This is affectionately known as a bubble gun. Basically what it is it's a half dome, a plexiglass half dome that's mounted over a seam or a lap, and then a vacuum pressure is applied. So what you do is you put a thin film of soapy water over the surface, then you apply suction pressure, and if you're getting bubbles, you've got a leak or a faulty seam. And then throughout this presentation, you've seen examples of thermal imagery. So this is an example of a thermal camera that is heat sensitive photography. If an area of your roof contains moisture, the moisture tends to stay warmer longer after a sunny day. And then early in the evening, that latent moisture can be detected by thermal imagery. Areas can be marked out and then verified later. For a lot of a new innovation in roofing design and technology, especially for modern high-rise buildings and buildings, say that are containing very valuable equipment. Let's talk about operating theaters and hospitals and labs and computers, buildings that with computer banks and things like that, where you simply can't afford to have a leak. Often what is being done now during design is a system called electronic leak detection and censoring is created as part of the new roof. Basically what you're doing is you're creating a field through which wires are run, and if moisture enters a zone in the leak detection censored area, an alarm is triggered, and it allows a quicker and more effective response to the leak. So electronic leak detection systems are being used. An example of a system like this is at the Edmonton Valley Zoo, where on one of the newer buildings where they knew they were going to have a garden roof, which is difficult to find leaks in afterwards. They put an electronic leak detection system so that should there ever be a leak, they can get to the area quickly and effect the repair more efficiently, rather than dig up the whole garden to get at the membrane. So these are examples of electronic leak detection in roofing. It shows you how the water enters the zone, an alarm is triggered. If you don't have a built-in electronic leak detection sensor field, you can use a version of divining rods like this fellow is carrying here. This is also called electronic field vector mapping. And the technology it's pretty involved and labor intensive to create the electronic field vector and have it mapped, but it can be done in situations where pervasive leaking is occurring, and it would be very costly to dig up the roof to get at the source. Our last section today is dealing with drones, unmanned aerial systems and roof applications. As drones are gaining popularity in the world and just in general, they're a lot of fun to fly, and the cost of drones are coming down. Obviously, there's been interest in applying this technology to roofing. So let's talk a little bit about how drones are being used in assessment of roofing and roof moisture surveys. Most drones are not equipped with thermal imaging cameras. Some are, but most drones that we're using for roofing are not equipped with anything special other than video camera. And so you can send a drone up to do what would be difficult for a human being to get at safely. So that's probably the biggest reason why drones are finding favor in the construction area. More expensive drones, better drones, and commercial drones, we'll call them, are equipped with thermal imaging. And so these drones are now being used to sense for and detect for moisture entrapment in commercial roofing. So the scans are done in the hours of darkness. And in order to do this lawfully and safely, the operators of such equipment need to have an advanced certification as provided by Transport Canada. And they have to file flight certification and check in with NAV Canada. You can't just, or you shouldn't send your drone up at night to do a moisture survey without having that in place. Drones that fly at night have to be equipped with lights. They take off like this, and during the daylight, you can create images that look something like this, where you can capture a large area of a building in a short period of time. You can see where problems might exist in the roof very quickly. You can hover, you can zoom, you can get close to these areas without physically having to get on top of the roof. This roof is a TPO membrane. In wintertime, these are extremely hazardous to walk on. So if you can send a drone to do what you can't safely do, that's a great opportunity. This is a thermal map of Mount Royal University in Calgary. So thermal is in a grayscale here. But to show you the efficiency of drones that are properly operated and properly equipped, this entire campus was scanned in less than an hour and a half for a team of 2 guys to do a roof condition assessment of each of these roof areas would probably take between 3 and 4 days. So being able to fly over a large campus, relatively large campus, in an hour and a half to see if we've got areas that may potentially be entrapped with moisture is a considerable time saving. This is what's called RGB, red, green, blue, which is basically what your eye sees captured from a drone of the same campus that you just saw in infrared. So what kinds of things can drones see when you have roofs that may become entrapped? Well, you see moisture. So the picture is kind of small, but you can see areas where moisture has been accumulating and has wound up entering into the roof system. It's just different examples of school buildings. And that brings us to the end of our slide presentation. So Corey, take us away.
Yeah, you bet. So actually, we got one final poll question there. I guess we'll put it up since we do have a few minutes. Opportunity for any of you to ask any additional questions you have of Gord in the last 10 minutes here. But the last poll, we just kind of want to know, have any of you used this type of equipment? So thermography, scanning, drones, anything like that Gord has just discussed to undertake testing or have hired somebody to do that on your buildings? So, yeah, it looks like about half of you have. So we have one question here for you, Gord. It says, are we able to get a recording of this presentation? I know that we can provide a copy of the deck. I'm not sure about our capabilities of providing a recording of the webinar. Maybe Rui, who is working behind the scenes, can answer that.
The short answer is yes.
There we go. We're also going to send you, when we send you a copy of the slide deck, you can reply back to me if you want a copy of the recording as well too. I am also going to send you just a little bit of a survey. Let us know how we did. There's a lot to talk about, as you can see from Gord's conversation. And I mean, for each of those components, you could have an hour-long conversation about each one. So if you guys are curious or you want to know more information, I encourage you to reach out to Gord and discuss. He's always available for further questions that may pop up after the stuff. Anyways, with that, if there are really no other questions, I want to thank you all for your time and your patience. If you need CPD credits for this course as well, I know BOMA, the ones that I do, I know some of the ones that Gord does there as well, are for continuing professional development. Let us know. We can always work something out to provide, documentation for your accreditation. So, and that's it. Thanks, everyone.
Corey, I think there's a couple of questions I can see on my.
No, we were able to get a copy of the recording. We answered, and thank you. It was great from Dan, and we appreciate the comment, Dan.
Thanks everyone for hanging in there. We know this is there's a lot of information that was shared today. Again, you've just completed probably a week's worth of college training on roofing, and you had to endure 2.5 hours of it with me. So thanks again, everyone. Appreciate you signing up for this, and we are available to answer any questions or provide support to you in the future.
All right. Take care.
All right.